Here we go. Okay, what's up, everybody? Finally into the actual doing of this. Yeah, so Emma's just said she couldn't make the first one, and no, Liz did. But I'm going to just quickly recap why we're kind of building in these sessions and doing them through the vantage point of data. So anyone who was here on the first time would have seen these slides. So I sent around a survey before our first session to try and just elicit a few kind of data related nuggets from the agency. One of which was there was actually quite a lot of parity in people's understanding of and confidence kind of using data. So the focus of obviously these sessions over time is to reduce that parity and get us all feeling more confident and more able, because that will result in better and more data-led conversations. Another data point to come out of the survey was the fact that basically as an agency, we split into three buckets. Some people who feel very happy using numbers, some people who really don't, and some people who are kind of neither here nor there. So that I see that as quite a powerful opportunity to change people's mindsets. If you can go from a place where numbers felt very difficult to you to a place where they did, that's quite transformative in your own little kind of working life confidence, and that's a good thing. And finally, that people said unequivocally that they wanted, they would at least tolerate having some skills training in regards to data at work. So I'm more than happy to provide that for the hordes of people who turn up to the call, or just the passionate few like yourselves. So here we are. Here we're doing that. And last time session, for anybody that was here, kind of focused a lot of empowerment, just really iterating to people that yes, you can do data science and be a scientist just by understanding the outputs and having a few basic skills, applying the right frameworks and having the right mindset. None of that at all is kind of hyper technical or needs a degree to be done. It's just a few training sessions over a short period of time. And there was lots of shit like this where I was making that point over and over again. This time round, we're going to focus a bit more on skills and understanding and do kind of more kind of hands-on practical stuff. And hopefully that will ladder up into everyone feeling a bit more confident and prepared to have more and kind of better conversations with data. And we're going to do that through the lens of a little scenario that I've created, a story that involves time travel. So if we're ready for this, and the high octane in the like it should be the like 20th Century Fox or something about to happen on the screen. Okay, if we're ready, that's great, and let's go. So our story begins as follows. You are at home one day, minding your own business, when you hear fucking spelt wrong. When you hear a big crashing sound. The crashing sound seemed to be coming from your bedroom. Cautiously, you get up off the sofa and creep up the stairs to go and investigate. Oh my God, there's a time travel vortex in the wall. To check that the time travel vortex is safe, you find a discarded object and chuck it down the hole.
Oh my God.
Gutted for anyone who likes ABBA here. There it goes.
I'm highly offended.
Into the vortex. So then you lean in for a closer inspection, and before you know it, you have found yourself careering headfirst through time and space. I've saved you all the audio of this. So there you go, through time and space with some Chris Packets and Lionel Richie. Suddenly, with an unceremonious thud, you find yourself, laptop in hand, in 14th century Constantinople. Artist's impression of 14th century Constantinople. From this place, we move to, if you would all like to consult the messaging like channel on here, you'll find a link as I share a different screen to the one I'm sharing now. Bum, 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 bum. Doof. Okay, so I've just pivoted to a screen that you all will be able to reach as well in your own time. which is a shared Google sheet that carries our story forward. So you've ended up in the dock at 14th century in Constantinople, and a priest stumbles towards you. He utters, "I've tried my best, but I'm afraid I cannot continue anymore." He falls dead at your feet, leaving you just a small scrap of parchment. You quickly type up what he has scribbled down below. So obviously the box here is your scribblings, and everybody can do one of two things. Either you can just keep watching my screen as I go through the stuff, or you can hop onto any of these other tabs that are currently without names through the link that you've got, and kind of go along with it whilst I'm doing it and have a kind of play yourself. So feel free to do either of those things, and yeah, I'll get cracking with going through the steps myself. Feel free to rename the tabs if you want to as well. So things we covered in the previous section, training session in only an ultra top line manner were obviously the data science process and the kind of journey you go through from being presented with a problem to coming up with a solution. And one of those early steps that we talked about kind of demystifying is data transformation, which is just a highfalutin way of saying getting the data ready for it's being used. It's like turning it from a relatively usable state to a much more usable state. So if we look at our little data set here, what the priest had written down on his small scrap of parchment, we can study each column one at a time. So he's done all right at first because every column has a header, which a data set is going to need. You can't get away with having a column without a header at the top, so that's a plus. All of the names seem nicely put in the name column. Family size presents us with our first kind of issue, which is that in any column, all the data types have to be the same. And obviously in here, we've got a mixture of numbers and numbers written as text, which is going to stop us from doing any analysis because obviously the computer itself can't do a multiplication, division, or any formula on a piece of text. So this, fortunately, is a very easy problem to solve because instead of getting a number, he just had them write down the number. So we can replace the values very easily. We can go from a bad value to a very accurate value very simply just by subbing the 8 out for an 8 and the 5 out for a 5 and the 6 out for a 6, and then just hover over them just to make sure that we've actually got it as a numerical value put in. Sometimes columns will be saved as plain text when actually we want them as numbers. So you can just click on that, and then we don't need the decimal points, so they can go away. So that's all good. That's gone from a tricky, like poor column to a good one. Has symptoms is the next opportunity for some learning. So we've learned about data types. In any one column, they've all got to be the same. Well, we've got that here, but it's a general rule that numbers are easier for us to work with than text when we're doing kind of obviously machine learning or data science or just any kind of numerical analysis. And a way of turning a yes/no column into a numerical column is by using the if formula. So to take that one step back, lots of the formulas in Excel or any other language rely on a certain understanding of just the logic. And at the most basic level, you can use different formulas that will just evaluate a statement as being true or false. So if I said, for example, if I've got the 0 here at the top of the pet rats column and the 0 here at the top of this column, if I put if I'm like equals that, it will come out as saying true, because that little formula of putting two equal signs together isn't just that's become a logical statement now versus a just a sum or anything else. So you can use that within the context of the if statement. So you can go and this is like so easy to do. It's just like if, and then you do a little bracket, and then you click on your thing, the right cell, and say equals. If that equals yes, which is very, very straightforward, it's saying D6 equals speech marks yes. Okay, well, if that's true, if it agrees with that, then we can have that as a 1. And if it doesn't agree with that, i.e. it's a no or something else, we can say that's a 0. And you can do that, and then you can always use the corner of any cell to drag down to apply that same logic to every cell below. And this has got the posh data science name of one-hot encoding, but really it's just as simple as using an if statement to change the columns in a thing. So as quickly as that, you've learned about the if statement. Next, we've got all the professions, and they've all been nicely applied, so not much changing is required there. Number of pet rats is the next column. So sometimes when you've got missing values like we have here, we've got these confused values, some are numbers, some are text. Sometimes when they're missing, you can do an accurate inference of what that number would have been. So in the case of the number of pet rats, we know that if someone's put no there, they probably mean 0. If they've been asked about what pet rats that they've got and they've just said no, well, that probably means a 0. That's a reasonably accurate inference. But what do we do when we've got a yes? So this person has basically said, yes, I have pet rats, but I haven't specified what number they are. Obviously, when you're doing data science, you want as many observations as possible. Each of these rows is a new observation. But sometimes if the data quality of any single observation isn't very good, you want to delete it. But we've got an opportunity here to just save this row, we save Irma's row by just making it a smart inference about what this value could have been. So we've got a chance to do that through learning about another formula. The next formula is the average formula. So if we said that a good assumption for this, for Irma's number of pet rats would be the average that any other person in this little data set had, all we have to do is put equals average and put a bracket and then just pull down over this column, and it's going to come up with 2.11. And if we knock all of those, you can use this little button up here to decrease the decimal places, which in this case is basically just going to round it down for us. We're going to assume she has 2. And you just copy and paste that across and ditch the extra decimal places. And then you've made a really kind of pretty smart assumption about what that value could have been and kept that row in the observations. So visits from Priest kind of follows perhaps a similar dynamic. If someone said no, they kind of mean they've had none. And if for anybody following along with this and their own thing, you can guess that we're going to use that average formula again to suss out what how many visits this person may have had, how many old Ludovic might have had. And this is actually a critical step. This is in the kind of dealing with data, is that replacing missing values and just dealing with missing values, whilst they're kind of not a terribly exciting thing, can be really pertinent in terms of you assuring you get to the right conclusion in the end. Because obviously Ludovic carries loads of different, more accurate data points, as did Therma, and we may have lost them if we just had to lose any of these one points. This is looking in much better shape already. Recently traveled to the Far East. So we've got some gaps in this column. And obviously, as we know already, we can convert the yeses and nos into ones and zeros, and we may do that in a second. But also we've got these gaps. And there's just no way we can make the same quality of assumption about whether someone has or hasn't traveled with that data set. So those are going to have to stay as gaps, and probably the best thing to do here is to lose this column. Sometimes data just has to make way if you can't trust its rigor and integrity. And then finally, we've got the now dead column, which gives us, just basically says in the yes or no fashion that we learnt from the has symptoms column, a 1 is sadly they've now died, 0 is that they are still alive. So with a much cleaner looking data set now that's been transformed and way more usable for us, we now want to move on to kind of doing some analysis, just understanding that data set a bit more. And we can do that with a few more simple uses of formulas. So for a start, if we wanted to figure out just how bad this situation is, obviously you've turned up in Constantinople in the 14th century. This is a key point in the transmission of the Black Death from obviously the Far East through into Europe. This is a very significant moment in history. We want to see just how bad it is in the population as we have it here in our little data set. And we can do that by firstly figuring out, well, what the percentage of these people that the priest managed to reach are actually dead. So firstly, we can figure out how many people are dead of this little data set by using the sum formula, which some people may have used before. This is literally just going to count, add up all of the values in the now dead column. 14 people have died from this little data set. Well, that's only so interesting. We kind of also want to know how many people there are, and we can figure this out by using what's called the count formula. So whereas the sum formula is going to add up all of these values one at a time, the count formula is just going to go, well, is there a numerical value in this cell? And if there is, I'm going to give that cell a value of 1. And if there's not, I'm going to give it a value of 0. So when you do that, we realize we've got a 18 strong little data set of people, 14 of which have died. And if we wanted to put that into just a single percentage, we'd obviously do the both things together in the same formula with just a divide symbol in the middle. And I know some people, like on the lower end of our data parity scale, aren't super confident using percentages and stuff. So hopefully that's a little learning, and you can just click the percentage button up here to turn it from a decimal point into a percentage. So that is interesting. Another interesting little formula and way of analyzing a data set after you've transformed it is understanding the variability in any one column. Like we've looked at averages already to get to our inferences in these columns, but actually it's one thing to know the average of a column, but an average can be a very steady, like today's a bad example, like usually the temperature across any given day is quite steady. It just moves in small increments up and down, and perhaps through the course of the day stays basically the same. But other data points in other data sets could have the same kind of average after all of that, but at one moment be very high and one moment be very low. And that variability we describe as standard deviation. So you can use that little formula here. If you just put STD, all jokes aside, no, it's STI, isn't it? No jokes actually apparent, into that cell, and you click on the one with the P on, it's just known as the most accurate for this kind of task, and hover it over a column. If we choose family size, it has to be a numerical column. It will tell us just the variability. So that 4.04 is just saying, okay, well, I know the average number of people, which if we quickly did it for family size, you know, the average size of a family in the priest data set is 7, and there's a variability on average of plus or minus 4.04 above and below that. And if we contrast that perhaps with the the number of pet rats, for example, that's another numerical column. We'll see that there's only a standard deviation of 1.9 because, as we can tell with our eyes and intuitively, that there's obviously no people tend to have less pet rats than they do family, like members of their family, and that in and of itself creates a lower average and a lower deviation, and they may seem like screamingly interesting data points for this exercise, but that takeaway that variability is as interesting as the average in our understanding of the data set is really interesting and really valuable. And the last thing worth covering here is some people like figuring out percentages, but less confident with figuring out rates. So if we wanted to know from this little data set the rate of the number of pet rats there were versus the number of dead people in the population, or people in the population overall, is probably a better measure, we'd use our sum function to add up all of the pet rats, and then we'd use our count function to remind ourselves of how many people there were in our little data set. And then this 2 is telling us, okay, well, for each person in the population, there's actually 2 pet rats, which if you were to scroll back 600 plus years and to be at the heart of the Black Death, that would have been a really useful measure. Knowing the number of rats versus the population was no doubt a good predictor of the movement and transmission of the Black Death. So we're whistling through at a rate here, and in this short time we've learned about data transformation and making sure the data types in each column are all the same, and about replacing missing values correctly. Sometimes we have to lose data, sometimes we can make a good inference and assumption for something that's missing, and we've kind of started to analyze it and understand it a bit more closely. We know what percentage of people have died, like almost 80% of the people in this little data set have died. But of course, we want to get close now to actually the solving of a problem and the understanding of things more closely. And there's a good way of doing that, and that starts with perhaps adding more features and columns to our little data set. Like the data that you're presented with in any given situation isn't the kind of finite tool that you have to use. You can understand dynamics within this small data set that may be in and of themselves better predictors for understanding the problem you're trying to solve, which in our time travel case is like, well, how do I stop the movement of this disease through Constantinople? And we can do that through thinking of a new formula. So yeah, we've learned about if, we've learned about average, and we've learned about standard deviation, and we've learned about sum and count. Another formula that you can use is called and this is just giving you a chance to put some of those more little logical expressions into it, and it will tell you whether that's true or false. So if we did it, for example, if we did, okay, well, say we call this column, okay, pet rat plus priest visit. So if someone has both got more than one pet rat and has been visited by the priest, we want to know whether that's true or not. So we just go and click on that column, and then instead of using the equals, we're going to use the greater than or less than signs. Greater than, as we know, is the little arrow that points to the right. Less than is the one that points to the left, but we want greater than 0. So that little expression is just going, well, is that is that value greater than 0? And then you put a comma, and you can do the same for the now dead column. So is that, no, not now dead, we want viewed from a priest. Visits from a priest. Okay, G6, yeah, is that if that's greater than 0 as well, then we want to know. So we'll scroll down. So obviously now we've got our trues in this column as people that have had both a visit from the priest and has a pet rat, and the falses just don't meet that criteria. They either have had a visit or have a pet rat, or neither. Another interesting way of coming up with new features is to create kind of new categories of your own. And you can do that using another formula, which we learned about, the if formula just then. Well, if you just add an S to this and it's the ifs, you can smoosh a lot of these conditions, these logical expressions together to create little values of your own. So in this sense, if we wanted to say, okay, well, it's a bit confusing for us to have all of these different values for family size, I kind of just want to know whether someone's got no family or a small family or a large family. We can do that in here. So if we did it like if click at the top of the column, if that is equals 0, obviously that's going to come out as true. For anyone that has no family, you just go no family, they live by themselves, and then another comma. Then if we did the same thing on the same column this time and said it was less than or equal to what's a small family size, so less than or equal to 5, then that's a small family. Or if something is greater than 5, it's big family. And it really does help when there's another learning, if you're going to create category names, make sure you can spell the word small. Cool. So now we've got a new column of family categories and a chance to learn something new. So these numerical variables have the data science name of discrete continuous variables, because obviously they can exist on a huge spectrum of numbers, which obviously is like infinite. Whereas the profession and our new family categories labels are called discrete variables, and whilst you have to be careful how you use them in terms of doing bits of analysis and prediction, they can be really useful when doing visuals and creating columns, etc. So with our new columns in place and our new features added that tell us something a little bit different about our data set, we can now use them to do bits of analysis. And we're going to do that using, and this is the final thing we're going to learn today, which is the use of a thing called a pivot table. Actually, it's the second to last thing we're going to learn, because in a pivot table, we want to make sure that each of the observations, each of these rows, it knows are unique. And currently in our data set, we've got multiple people named Tariq, Maria, and Lucas, and we don't want those things being counted twice. So this is why, and you'll often see it in any data that you've seen in your working lives, that there's often this complex or lots of numbers column, which is called like an ID column. And that's only function is to make sure that observation is a unique one. by having its own unique address. So if you just put 1 and 1 into that column, and then in the cell below, you just say that plus 1, you've got a very, very, very simple way of making sure that the pivot table knows that actually these are all unique entities and observations. They are not they're not one and the same if they've got the same name. Cool. So if to create our pivot table, as you would in Excel, you just hover over your data, and in this case, you go up to data and click on the bit pivot table. So go to the data bit in the ribbon and hit pivot table. And it's easier to put it in the existing sheet, so we'll stick it down here. And pivot tables are basically just a really kind of nice, intuitive way to take different elements of your data and see them mapped together, versus having to chop and change it and move it around or just look at different bits of it. So obviously we want to get close to answering the question of, well, what's causing these people to die? What's going on in Constantinople at this time? So if we, in our data set, if we tried using one of our new features to try and figure this out, so you should see, if you've opened it up, that you've got this pivot table editor bit down the side, and it's the same in Excel. Maybe we wanted to understand our family categories and whether that was a good predictor for why people were dying. So if we put, actually we use our categories instead. Cool, so you can see our labels in there, and then in the values section, we want obviously our now dead column. And perhaps it's not surprising to see that those people in larger families are dying. There's more of them that have died. But if we look at the average, yeah, that's proving to be quite a strong predictor. But also we can see that the one person with no family also died. So it's like, that may not be the best predictor after all. We always want one that's highly correlated with our outcome. So that might be a non-starter looking at our family types. And you could do the same with any other variable. Say we wanted to look at the number of pet rats, and obviously these things sitting in here is just the average for the now dead column. So a 1 represents saying that everybody with such and such level of what's in this column has died, and obviously anything less than 1 is there's some people who have survived. And again, with pet rats, we're seeing a slightly mixed bag. There's just lots of people that have died and lots of people still who have survived despite having pet rats. So that may not be the best predictor in and of itself. What about the other of our new columns? So if we put in the pet rat plus priest visit, okay, well now we're starting to find something interesting. So in this, we've seen that, okay, we know that true is anybody who has pet rats and has been visited by the priest. Every one of those people has died, whereas only half of the people who have one of those things haven't died. So that is already a clearer signal for perhaps what's happening here than we had before. So then to follow that further, it's like, well, let's have a look at the visits from a priest. Actually, what we can see here is that, I don't know why the 1's coming up twice, but assuming that it wasn't, we're seeing this increasing gradient, this increasing percentage for the number of visits that they were had. So that could in and of itself be a clear signal that, or perhaps the visits from a priest, and we know from our story earlier that the priest has died. He fell dead at your feet, leaving just a small scrap of parchment. So like that is a really interesting steer. So is that the heart of our problem? Would it take more time to solve and figure things out? Obviously, it would do. But in going through all of these steps, we had a mix and match data set at the start, which would have meant we lost columns and that it needed some transforming it to make it really usable for us. We then, once we tidied it up, we added new columns that gave us better predictive ability and able to put us things in categories to make things simpler. We added our ID to make sure that the pivot table knew everything was its own little observation. And then we started to use a pivot table to see what might be the most predictive elements, or what any one parameter, what might be the most connected with why people were dying. And it looks perhaps as if the priest, if only the priest had self-isolated and stayed at home after demonstrating symptoms, he may have saved the lives of some of these poor people that have died in Constantinople, and may have stopped the transmission of the Black Death throughout Europe and everything that followed. But who knows? We will explore more about how you can make more confident and statistically significant assertions about these things that you're seeing. But in this little journey, we've moved from being thrust into the middle of a problem to trying to use what little data we had to make it more usable, to understand it better, and to come to some tentative solutions around why what's happening is happening. And in the hope to have done that in a more interactive way, and I realised I've just spoken ad nauseum for a long time. Anyway, so this has all been recorded, and I hope that it has made some sense. And I hope that it has been interesting and more immersive than perhaps the previous session was. I really, really appreciate you guys jumping on the call. And if you did have any questions about things that I skipped over too quickly, or things you'd like to learn in a future session, it would be lovely to hear from you, and I'd appreciate that feedback.
I have a question.
Yeah. Have a lovely rest of the day, and I really appreciate you taking the time.
Can you hear me?
Yeah. I can hear you.
I have a question.
Rich can hear. Can Rich hear?
Sorry, yeah, I realised that I put my thing on mute, and so it's like your little circles were popping up and down. I was like, I can't hear anything.
I had a question.
Yes, yeah.
So you know when you deleted the column about the Far East?
Yes, yeah.
So why would you delete the column rather than remove the individuals who didn't have that answered, you know, in a correct way? That's
actually a brilliant question. I did so in the moment of which I was doing it to just simplify the exercise, but you're absolutely right that to remove those rows would have been a smarter thing to do, because it may have been that if people had a rat and visited the priest and been to the Far East, has been an even bigger predictor of things. So you're absolutely right that
okay, you could do it that way.
Yeah, to lose an entire column of data is obviously quite a big cost to impose onto yourself, and to lose the rows before the columns is definitely a smarter thing to do. You're absolutely right.
It depends on what is the greater loss, I guess.
Yeah, exactly. And you're constantly doing that little cost benefit. Is like, well, I don't want to make a load of rough assumptions here, and I don't want to have some ugly data. It's like you're constantly just juggling the balls.
Okay, good.
No, what a great question.
I joined a bit late. Sorry, my last meeting overran. But no, I just want to say thanks. It was a really fun example.
That was brilliant.
Creative to go. I just came in. I was like, Jesus, what is this about? But yeah, really cool. Funny back down. I think really relevant right now with Corona and stuff. People are starting to understand more like why data modeling is important to find the clues and understand.
Yeah, I might try and do some extension of it in future, because if I mocked up a data set that had 10,000 people in it instead of just 18, then we could see these little machine learning forecasts and predictions that currently sit in the news and stuff all the time. We're constantly having people been telling us, well, what's likely to happen with this or that, and we can see the variability. So knowing how somebody gets there is interesting. But yeah, nice to be a bit timely without saying that I had any of the ideas of what solves the coronavirus, which of course.
That was my next question. Yeah.
Also, I mean, the government uses Excel, so why can't we do the same thing?
No, exactly. It's a very good tool.
Very good. Yeah. Well broken down, Rich. It was really good.
Yeah, it's brilliant.
Yeah, really, really good. Thanks, Rich.
No, a pleasure. Thanks, guys.
That's great. Thank you.
Great
Be
rest
sure
of
to
your-
send it round.
Yeah,
Yeah.
I will.
Cheers.
Thanks,
Rich.
guys.
You guys.
Thanks, Rich.
Bye.
Bye, bye.